Register for AP test. Okay? Then Saturday thingy, because I'm videoing this. I'm giving the highlights to my people that watch this video. Shout out to my subscribers. Y'all, I have like 30 subscribers. I don't want to brag, but yes. No? YouTube's gonna start paying me soon. Okay, register, AP Saturday, and let's go. I'd already put the comma, so I had to do it. Okay, here is the product rule. Are you ready? The derivative of f of x times g of x is f of x g prime of x plus g of x f prime of x. Okay, write it down. Okay, then I'm going to give you what I think is an easier version without all the parentheses and x's and all of that. Okay, so what I'm going to use is this guy, d dx of u times v, u v prime, v u prime. Okay, so this one to me is a lot easier. This is the official product rule, but I'm going to just shorten it so that we can do it more easily. Now, before we start doing examples, we're going to make a yes-no list of what you would need product rule on and what you wouldn't need product rule on. Okay, so this is going to be yes product rule. This is going to be not need product rule. So we're going to make a little yes-no list. If I was taking the derivative, let's say d dx, remember that means derivative, of x cubed times sine x, you would need product rule. Because you're multiplying what, two things? X cubed and sine x. You would not need product rule if it was the derivative of 3 sine x. Now, here's the difference. 3 times sine x is still a product, but 3 is just a coefficient. So on its own, it's not really a function. So if it's just a number in front, no product rule for that. What's the derivative of 3 sine x? 3 cosine x. No product rule. But if it's two things multiplied together where they're both functions, you need product rule for that. Okay, one more example like that, d dx. Okay, if you had the square root of x plus 2 times, we'll say, e to the x. Okay, you need product rule for that. Okay, one of them's a square root function, one of them's an exponential function, they're multiplied together, that means it's a product, you're doing product rule. Okay, you would not need it for this guy. Now, here's why. What can I do to avoid product rule on this example that I can't do on this example? Someone already whispered it. Distribute, right? And then it's not a product anymore. So I can fix this. Okay, just times it in. 3x2 times x4 is the derivative of 3x6, 15x squared. Now it's not a product anymore. So if you can easily fix the product to not be a product anymore, then just do that. Okay? All right, are you ready for an example?
Yes.
Okay, first example, number 1. You are going to take the derivative, you may, of 3x squared times sine x. Don't get pantsed. Okay, first thing I want you to do is underline u and v. So u is the first part of the product, v is the second part of the product. I'm going to write them over here. So u is 3x squared, v is sine x. Then I want you to take the derivatives of both parts. So if u is 3x squared, what's u prime?
6x.
Okay, 6x. If v is sine, what's v prime? Cosine x. And then if you look at your little short rule that I made you right here, you're going to do uv prime, that's this diagonal, plus, and then you're going to do vu prime, which is this diagonal. So that, I think, makes it easier. So I would put it equals 3x squared cosine x plus, and then the other diagonal would be 6x sine x. Easy.
So that's the answer?
Yep. Now, for AP, one of the things that they do on multiple choice is they're always going to take any GCFs out of your answer. So, for example, if I was doing that, what's GCFable for me to take out of that? 3x. Good. So I'm going to put or, take a 3x out. What would be left over from 3x squared cosine x? X cosine x. And what would be left over from 6x sine x? 2 sine x. Now, technically, these are the same thing. But if they were going to give you a multiple choice answer, okay, they would probably write it like that. Okay? But for if it's free response, this is perfectly fine. Good enough. You don't have to do that. Just if it's multiple choice, they will. Okay? Can we do another one? All right. Number 2. Can I go? Good? Some of you look like you're still writing. Are you sure? Okay. Here I go. Okay. All right, next one. Number 2. We're going to take the derivative. Y equals, it's going to be square root of x cubed times cosine x. Okay, underline each part of your product. This is the first part, this is the second part. When I write my u, though, the square root of x cubed, how can I make that like a power? Make it x to the what? 3 halves. So remember, I put the power on top is 3, and then if it's a square root, that's a 2 root. Okay? So u prime and v prime. Let's do u prime first. So remember, I times that number down, so now it's at 3 halves. And then when I take away 1, I'm kind of like minusing 2 halves. So what's 3 halves minus 2 halves? 1 half. Good. Okay, other one, it was a cosine, snow cone, snow cone. What's the derivative of cosine? Negative sine x. Very good. So then from there, remember, I'm going to do this diagonal plus that diagonal. Okay? So if this is y, my derivative would be called dy dx. Or you could call it y prime. Doesn't matter to me, either one. And then I'm going to do 3x to the 3 halves times negative sine x plus 3 over 2x to the 1 half times cosine x. Now, AP also, they're not going to leave these guys in this form, so we're just going to convert those. Okay? So if it's x to the 3 halves, that's the same as what? X is cubed and then square rooted. Also, they're not going to leave this multiplied by negative sign. They just put the negative in the front and then the sine x behind it. Okay, then for my x to the 1 half, that's really just a root x times cosine x. Okay, and they'd probably just leave it like that. They probably would not pull out a square root x just because that'd be annoying. Make sense? Questions about that or no? Not so far? Okay. So next one, we are going to find x values for horizontal tangents. For f of x equals your function is going to be 5x ln x plus 4x. Okay, now let's talk about horizontal tangents. That was on your quiz yesterday. Hopefully you remember how to do it. What do you do? Yes, and then set it equal to 0. Remember, a horizontal tangent is a 0 slope, and if I want a 0 slope, then I'm going to set f prime of x equal to 0, and then I'm going to solve, right? Okay, just like you did on your quiz yesterday. When I take the derivative, though, I'm going to have to use product rule. So, underline the parts of your product. Okay, those are my two pieces. So, my u is going to be 5x. My v is going to be ln x. Okay, what's the derivative of u prime? 5. What's the derivative of v, which was ln x? 1 over x. Very good. And then remember product rule, you just add your diagonals. So I'm going to put f prime of x equals. I'm going to do this diagonal first, just like I've been doing. Okay, and then I'll put the other diagonal second. So it's going to be 5x 1 over x plus, and then this diagonal would be 5 ln x. Now, notice that that's not the end of my function. I had my product, but then plus a what? 4x. So the derivative of 4x would just be a plus 4. Okay, from there, after I take the derivative, what slope do we want? 0. So I'm going to do 0 equals. And what can happen on this term right here? If I have an x and a 1 over x, that's really just a 5. Are we good with that? Okay, x and 1 over x basically cross out because you have an x on top, x on bottom. So I have 5 plus 5 ln x plus 4. Okay, what next? We're solving. Can I combine anything? Okay, the 5 and the 4 make how much? 9 plus 5 ln x. What next? Minus the 9 across. So now I have negative 9 equals 5 ln x. Okay, divide by 5 next. So now I have negative 9 over 5 equals ln x. Okay, on your quiz yesterday there was an ln or an e and you crossed out with an ln. What if you start with the ln? You're going to e both sides. So e will be the base on this side, and then e will be the base on this side. And anytime I have an e to an ln, they still cancel out with each other. So e and ln are gone. Bloop, bloop. X equals negative 9/5. Or you could do 1 over e to the 9/5. Okay, but keep in mind that those are the same. So anytime you have a negative exponent, that means really it just belongs on the bottom. Yeah? Good. Yes. Yes. Yes.
Hey.
For the first two parts, that's what U and V are, that plus 4.
So that's not part of the product. So that's why we just kind of added. I needed the product rule for this part, but the plus 4x, I'm just taking the derivative of that on its own. And that's where the plus 4 came from here. Sure. To there? Okay, are we good on that? Okay, so hopefully I have 7 examples, so maybe we'll get at least through 6 of them.
It is.
We got like a solid 15 minutes, okay? No, we don't. I can't tell time. We have 8 minutes.
One more.
Should we take a break?
8 mince.
Yoshi. What do you need a break for? Okay, if we'll do 1 more. Compromise?
Alright.
2 more.
Oh, 2 more. Because listen, if we don't do them today, we should have to do them tomorrow, you know?
1 more. 1 more.
5 more. I don't even have 5 ready for you. Okay, number 3. Or is it number 4? Oh, look at us. We could finish. Just kidding. Just kidding. Okay, find x values of horizontal slopes for f of x equals. We're going to do e to the x 3x plus 9. Okay, review the plan. How do you find a horizontal slope? You take the derivative, set it equal to 0. What kind of rule am I going to need to take the derivative? Product rule. So u is going to be what?
E to the x.
E to the x. V is going to be what? 3x plus 9. What is u prime?
E to the x.
E to the x, the derivative is its own self. 3x plus 9, what's the derivative?
3.
Just a 3. Now from here, I would go back and any terms that have more than one thing, I'd put parentheses around it so you don't forget to put them. So here's my derivative, f prime of x equals. I'm going to do this diagonal first. I'm going to do this diagonal second. E to the x times 3 is 3e to the x. And then I have plus. Then I do e to the x times 3x plus 9. From there, what are we setting it equal to?
0.
0. And we're going to solve by factoring. What do both of those have in common that I can GCF out?
3.
Okay, ignore the 3, you're right, but let's wait on the 3. Let's pull the e out first. So my e to the x is going to come out. What is left over from the 3e to the x? 3 plus, what's left over from the second one? 3x plus 9. I'm not going to pull the 3 out for now. You could, but I'm not going to. Okay, now, in that second bracket, is there any term that I can combine? Yes.
3 and 9.
Good. I can take out, that's 3 plus 9, that's really 3x plus 12. Are we good with that?
Yeah.
And then now I'm going to take out a GCF of 3. So, take the 3 out next. 3 right here, and what would be left over?
X plus 4.
X plus 4. So I have e to the x times 3 is pulled out, x plus 4. The reason I wouldn't pull the 3 out at the beginning is because if you pull it out apart, I mean, it ends up working out the same, but it's more confusing to me that way than to just put it all together, GCF at the end.
Is ex times 3 the same thing as 3e to the x?
Yes, you could also write it like this. That would be fine. 3e to the x, x plus 4. Doesn't matter. Now, originally, what was that equal to?
0.
0. So what are my solutions? So if I have a plus 4, what's my first solution?
Minus 4.
Negative 4. My other answer would come from when 3e to the x is 0. But when does e to the x hit 0?
Never.
Never. So if I set 3e to the x equal to 0, that has no solutions. So what that means is that my only answer is negative 4. Okay, if you think about the graph of e, it never hits 0. So that's why I don't get an answer for that. Okay? Good? Okay, the last one for today. Same instruction. Did I say that? I thought I said 2.
You said 1.
No. I changed it.
What is this?
Okay, find horizontal tangents. Y equals 2x to the 4th times 3x minus 4. Are you going to do it right? You've been in the bathroom half of the notes. Okay, here's your u, here's your v. Now, could you distribute that and avoid product rule? Sure, but I don't want you to do that. We're practicing product rule. So what would my u be?
2x to the 4.
2x to the 4. What would my v be?
3x minus 4.
3x minus 4. I'm going to group it in parentheses so I don't forget to put them. Okay, Kane, what's my u prime?
8x cubed.
Perfect. What's my v prime? Oops, cubed.
3.
3. And then remember your product rule? You just do one diagonal plus the other. Good. Okay? Yes, you would. So when I multiply these guys, right, 2 times 3, I can just make that a 6x4 plus 8x 3 times. Good. Then from there, if I want a horizontal tangent, what am I setting it equal to? 0. What can I take out?
The x.
Yeah, how many though?
3.
I can take out an x3 and what constant? a 2.
So you can't touch anything that's in the parentheses?
No. So then from there, my 6 divided by 2 leaves a 3x behind, plus 8 leaves a 2 behind, or a 4 behind, and then I still have the 3x minus 4 left over. Now in this case, what am I going to have to do before I can combine? In my bracket, you're going to have to distribute in here. And then after you distribute, you can combine and look for a GCF. So my initial thing is still a 2x cubed. Nobody cares about that. Okay, then I have a 3x plus, a 12x, thank you, and then minus 16. 3x and 12x make how many? 15x minus 16. And now you should be able to identify your zeros. If x is in the front, what's my first 0? 0. And then for my second one, I change the sign here. That'd be positive 16 over 15. Good? You get it? Okay, your homework has product and quotient rule on it, so if there's a divide by in it, don't do it. You haven't learned that rule yet. We'll learn it tomorrow. Good job! Enjoy your 1-minute break.
What?
What? And Mu Alpha Theta is after school today. You guys coming?
Yeah.
It's gonna be a party.
Yeah.
Math party.